So chapter 1, matter, measurement, and problem solving. Okay, so what do you think? What do you think is the most important idea in all of human knowledge? You don't have to answer that out loud if you don't want to. That's a big question, right? Big question. I don't know how I'd answer it. If we look at just scientific ideas, probably the most important idea is that the properties of matter are determined by the properties of molecules and atoms. So why does my raspberry lemonade taste the way it does? It tastes that way because of the properties of the molecules that are in the strawberry lemonade. Why does water put out fires? Why does wood burn? All of the properties of things that we interact with are due to the properties of the atoms and molecules. This understanding that we have gained of how atoms and molecules interact with each other allows us to, in large part, control the properties of the substances that we make. So, we make new plastics. Those aren't made by accident. They're made very intentionally, okay, because we understand what's going on at the molecular level. What is a molecule? What is an atom? Atoms are the submicroscopic particles that are the fundamental building blocks of ordinary matter. So they're the smallest pieces. I think of them a lot like individual Lego bricks. I have 6 kids, and the oldest is in graduate school now. So we've been collecting Lego blocks for over 20 years. We have a lot of Lego blocks. So I will use Legos as an analogy often. You think about the Lego bricks. Hopefully all of you at least know what they are. Those individual pieces, they're different shapes, they're different colors, they're different sizes. You can't take them apart because it's a unit. The individual bricks are one piece. But you can put them together in different combinations, and then you can take that structure and pull it apart, right? So that's how atoms are. It's rare in nature to see free atoms. There are some elements that exist that way, but most of them combine their atoms with other atoms, sometimes with other atoms of elements, and they make molecules. And so here we have an example of a water molecule. Water molecule is composed of one oxygen atom attached to 2 hydrogen atoms. So you could think of this as a little red Lego block with 2 white Lego blocks stuck onto it. All water molecules look like that. And so those are the molecules, atoms that are stuck together. The properties of that water molecule determine the properties of water itself. What are some of the properties of water? What is water like? It's a liquid at room temperature. Does it have a taste? Not really. Does it burn? No. In fact, what do we use it for? We use it to put out fires, right? We drink it. We need to drink it. Our bodies are composed largely of water, but too much water is bad for you and can kill you, either by diluting your electrolytes so that your heart stops or by drowning, right? So here's the water molecule. This molecule is a hydrogen peroxide molecule. Small difference between these two. This one has 2 oxygen atoms instead of 1. But that one seemingly small change makes a big difference in the properties of hydrogen peroxide. We wash our hair with water to rinse the dirt out. If you wash your hair with hydrogen peroxide, you'll wash all the color out of your hair. That's what they use to bleach hair, to remove the color, is hydrogen peroxide. If you get straight hydrogen peroxide on your skin, it's going to eat through your skin. Dilute solutions of hydrogen peroxide can be used to clean wounds. Hydrogen peroxide is also unstable and will decompose over time. Water is not unstable. So the properties of these 2 substances are very different, and it's due to hydrogen peroxide having 1 extra oxygen atom. Here's another example. This is graphite, like you probably have in the pencil that you're writing with. This is a diamond, which if you're lucky, you might have on your finger. Both of these substances are made out of carbon. They are just carbon atoms, but the properties are very different. Graphite is black, it's soft, it's slippery, it's cheap. Diamonds are expensive, they are clear, they are very hard, they're beautiful. The difference is how those individual carbon atoms are attached to each other. Here there's a three-dimensional structure of carbon atoms bonded to each other. In graphite, it's a two-dimensional structure with layers of these structures, and so they slide relative to each other, and that causes the graphite to be slippery. Makes it useful as a lubricant or as a writing tool. If we want to understand the properties of graphite or diamond, we have to look at the atoms and molecules that compose them. And that's the central goal of science, is to understand behavior of matter by looking and understanding the behavior of atoms and molecules. Any questions?